Hello everyone. So here I will be presenting you the project related to Thapar University. It's a project based on the library of Thapar University, Nalanda Central Library, the full form of NNCL. So what we have done is we have worked on a search optimization. As you can see, the objective of this project was to facilitate searching of books. What I mean by that is that when we went there at the portal of NNCL and we typed some book query like the title of a book. So if it was wrong, like Java would be if we misspelled it as JAA or something like JVA, then it would not give us the results. And most importantly, what it was, the problem was that when a person typed the title of a book and he or she doesn't get that book there because it had been taken by some other student or somewhat. So we are providing a solution to that person by providing some of the recommendations to that person related to those books. So he could get some other book uh, if he can't get that from the library. So main objective was that to fulfill that problem, to overcome that problem. Then the outcomes are first, because previously only SQL matching was being done, and now the user students can also look at the other recommended books according to the search, even if the query is wrong. So in this mainly, firstly, there are many methodologies, and a full structure is created for this, as we wanted to set up a generalized system so that on any library it could work. So this is the model which you can see. It's not very big and it's quite simplified here. So first, by what we mean by the pre-processed data is that you wrote something like business management. Now it could be that you wrote business, you misspelled business, or you misspelled some word simply. So it would correct that word according to the database of the words of the library, and and then it would give you the results. Or it would also segment it. Like what I mean by that, that simply if you write C programming and you merge them both, like you write C programming, no space in between, then it will also give you the results by separating them. Okay. That's simply done on the basis of bigram and trigram modeling. I will tell you that after later. Firstly, you can see that minimum merit distance and segmentation is being done, as you can see here. And then what we have used is, after that we have used word to vec model. Word to vec model is based on Kaggle bag of model. Actually, it's a neural net, you can say. What it does, it gets a title of the book, whatever you type there, and it takes that word and it performs one hot encoding on that, and according to all the words on which it has been trained, it forms a spatial structure, like in three dimensions there are points in the space. So what it does, it compares them, and it tells you what are the words most probably that will be most likely comparable to that word. Like if I would say C. So C programming, as we know, C is a language. So it would give you C++ and Java results as well, and other programming as well, and also the books related to C. So the word to vec model works like this, and then the DDC model is what, actually there is a classification number for each type of book which is standard for all the libraries, which is known as Dewey Decimal. So Dewey Decimal classification is being done on the model, and then we are generating the results. We also have clustered the data on the basis of the classes which we segmented, and then we have merged those results with the DDC similar words according to a weightage function, and then we have passed that to the word to vector model, and then we have compared the results here as well. And the SQL query matching is simply what was being done before, and we simply substring matching is done, and then the results are combined, and the final results are the outcome. So this is the first front end, and this is the output. How we get, we type a query in the box and then we get the output. So the methodologies include text segmentation, query correction, word to vec model, DDC label model, clustering, and SQL query matching. The tools and technologies are listed here which we use. These are the three members which were a part of this project. I am Chandan, Suri, and these are other two members of the project collaborated. Now, now I would show you the code a little bit to just give you a hang of it. So as you can see that we have a bit of a code here. I will not show you the data processing code because data pre-processing code because it's not a basic structure what it runs on. That was being done just for building this code at last. So um, let me first go at the last where you can see we have used Flask for the GUI creation, and yeah, you can see from Flask import Flask, and we have then what we are doing is first we are getting a here we're getting a request, and then this is a simple encoding structure. Then we have corrected the text according to the segmentation, and we have segmented and minimum distance we have applied on it. As you can see, this is the only text. First it gives the only text because we want the words only, and if there's some kind of number in between we don't want that because it would not matter much. And so it corrects the word according to the minimum edit distance, as you can see here, and edit 0 and edits 2, and these are the substructures which are used in the main structure for correcting the words. And this is the correct matching, like it matches with the most present there, with the most probable one, and it gives you a whole list of structures, a whole list of answers to it could be. And then it also segments it. As you can see, this function here, it is used for segmenting it. The like I told you that if the words are merged, it separates it. And after doing these two works, the main pre-processing has been done on the structure, on the input you gave. Okay. So then what it does is after the segmentation and all, it gives you the list of books. How? So as I told you, we had implemented a word-to-vec model, and I will be showing you that. This is the code related to that. We have used some number of features, some number of workers for like threads. Because if we use a number of threads, the processing will be faster. And as we have done, so this is the this simple flatten. This is nothing too much. So this is to calculate the similarity of the words that most probable words. This is our data actually. This is our data file. This is the DDC classification which we had done. This function related to that. What we have done to DDC classification, and this is the SQL query matching extract books. And at last, this is the main function which was being called as you saw before, list of books here. So list of books is this. So it calls first, as you can see, extract books direct, first does SQL query matching, and then on the words and tags, as we only want the nouns and the verbs to be there, so we have extracted only those to consume less memory, of course. And then we have taken final dot append. We have done the thing I told you, the DDC classification, as well as you can see here, TT was called before, and TT was called for in this DDC classification, and then the Kaggle model, and then the intersection of both is taken, and then the common books related to them are given to you. So this is how the code would work. Now let me show you the GUI, that how this works. The file name is py. I have used Python 2.7.14 for compiling this. Now it would take some time to train. This is the one-time process which we are doing, which I'm doing. This is not needed every time you would go for. So so it would load. As it is training on the model and neural, it is also going on. So it is taking a little bit of time, and it's just once. So not it doesn't matter much because every time it would not take this much time. Yeah, as you can see, it is a There's mostly a modular code as we have as we wanted it to be, because it should be modular. Basic, as you can see now, the progress is there. It is being trained on the model. This is the mainly the Kaggle. As you can see, there are worker threads here. As I told you that it is threaded. We have threaded it so that it could work faster. And as you can see, it shows you the progress as well, that this was the sentence, this was the sentence. These are the tuples on which we have trained, you know, structure. And as you can see, the number of vowels in our model, and this is where I would be taking you. So let's minimize everything. Let me take to. So this is the page. Welcome to an NCL search optimized home page. And now I would be running some queries to show you how this works. So let's start with business management. Let's say it's here. So of course the model created for the this, as you can see, it has been trained. So now what it does is business and management. It segments that too for now, because there was not. I would also show you that how that works. So business and management have been done, and then now what it will do, it will see that what are nouns. So it is a noun, so it would take that, of course, and it would fed it into the DDC, and as well as the Kaggle bag of model, and then it would give you some results on the basis of that, what are the most probable results to this, according to the weight vectors, of course, as I told you. So management, strategy, managing, strategic, planning, enterprise. Oh sorry, yeah, the results would be here. So here are the results. As you can see, industrial management, managing strategic innovation. These are all related to business management actually. As you can see, the personal management, industrial relations, and let me show you some more. Information sources and management and business, production planning and inventory control. As you can see, there's a planning word, and guess that it is related to this managing. So quality planning and analysis, product development. So it's all related to business management. It could be. So these are the results for this. They have not been ranked till now, but the results are quite good. We will be ranking them soon. Now let's take some other query. This is a subject of civil, so let's take this to see how it gives the results for us. Now again, if I show you, as you can see, soil mechanics, separate those, and all these things will be done on this. The training is done once. As you can see, this is not computed again and again. The model has been created. Now it only runs to get those most probable, most common words, you can say, which would be near to them in the spatial dimension. So as you can see, those have been generated successfully, and these are the results: soil mechanics, dynamic system, popular mechanics, dynamic behavior of foundation, engineering mechanics, and you can see all that, fluid mechanics. These are all related to those soil mechanics and engineering practice. As you can see, it magically appears that it gives you the results which are quite similar to this query which you ran. So it's quite good to see these results, of course. And it's generalized. It is not that it is made for this library only. It is generalized. It will work on all the libraries, hopefully. Now I would run some other thing just to show you. Sorry. Uh, yeah. So as you can see, Python for data analysis. Now I have gone to the computer science branch, to which I belong. So now you can see Python for data analysis. It segments it correctly. Python for data analysis. What it does, it gets the probability of a word, that how probable this word would be. You would be seeing that more when I would write something incorrect. I would be doing that soon. Just wait for it. So this Python is now, and as you can see, it doesn't get the results for because it is not. Yeah, and data is a noun. The secondary one gives you the result for that as well, and now it's calculating. As you can see, the data are visualization, black. As we know, there's a black book for data analysis as well. Hive, map reduce, warehousing, big data, as we can see. So it, analysis optimization gives you quite good results, and then it merges them. And here are the results. Python for data analysis. As you can see, there are good results here. Data analysis and graphics using R, modern analysis systems, and it also gives you some programming books which would be related to your data analysis part. R graphics cookbook for visualizing data. These are all the books that would be related to the data analysis part. So the results are quite good. Now let's run a query, simple one. Just let's see what it gives us. Now again a programming one. Sorry for that. So it's a simple query comparatively what we did before, having four words. Now you can see, so correct identifiers that the tagging has been done for this, and now it would calculate it according to the model which we have trained this. So, so now you can see PL, Java 2D, Turbo Pascal, C Odyssey, and other books, embedded C programming, Turbo Pascal, Perl, C++. It gives you all the books which are related to C, which are related to programming, Java Virtual Machine, Fortran and C. It gives you C language. It gives you quite good results as you can see here. Now I would show you that how it works when we type something misspelled. So let's misspell it. And we would. So this I would do. Sorry for doing this type of thing. So now you can see that business, it was there, business management. It had correctly identified as management, and it gave and now give you the results as we saw before for this same query. Hopefully you would see that a little bit within a little bit of time. And so the similar thing, you can see that it follows a structure, it follows a model, and it gives you the results magically. It gives you the results which are, and it is not magic, let me tell you. Took a lot of time to build this model. Yeah, so the results, and here we are, business management. See. Now let me tell you what I meant by segmentation. So let's type some other query, not this one, the board. Yeah. So let's type again this one, and I had done this before. Solid mechanics. So let's see. Fingers crossed. So it currently identifies that solid and mechanics, and then it would give you the results as well. So I just stopped that because I showed you that how it segments its solid into solid and mechanics. So now, sorry for that, because as I interrupted the server, so it has now stopped working. So this was all about this search optimization project. So hopefully I didn't give much of a time. Sorry for that if I took. Hopefully it would help a lot of students at Thapar University to search for the books, and I would be also doing that ranking thing for it because it's needed. And so if you can't find a book you want, explore the options instead. Yeah, that's all. That's a kind of motto. Yeah. Okay. So thank you everyone for watching this video. Thank you.